All right, well, we might get started and hopefully people will just keep arriving. We have to get through some just ordinary stuff to start off with, so we might as well get going. All right, just going to share this one to Daisy. Does that work? Yes, it should have. All right, hopefully everyone can see that in full screen.
Yep.
Yeah.
Yep.
So, good morning, afternoon. It's afternoon now, yes. Good afternoon, everyone. My name is Eloise. I'm one of the instructors with Coding Kids. So we run STEM and entrepreneurship workshops with 7 to 15-year-olds, as well as teacher PD sessions, as we are doing right now. We've travelled far and wide, delivering our programs to the Torres Strait, Longreach, Thargo, Mount Isa, and heaps of other places as well. So today we're going to learn how to code with Python, which is text-based coding platform, and it's a great starting point or continuation point to learn about computational thinking, algorithms, problem solving, and design. So the digital technologies subject is based on engaging students to create their own digital solve community problems. And Python is a very handy and effective tool in creating your own digital solutions. I'm just going to skip this one. Okay. So there are heaps of tools that are available to deliver activities for digital technologies, but today we're going to be focusing on Python, which is this one just here. And then in the future workshops, we're going to be looking at microbits over here. There we go. Let's see if I can do this. There we go. That's a little bit better. A bit smaller. There we go. Okay. So, although you might be teaching a class to build a project with Scratch in years 3 to 6, it's good to see the programming expectations from prep to all the way up to year 10. So in prep to year 2, students learn sequencing of steps in real life or in storytelling. And then in years 3 to 6, students learn visual programming, so writing algorithms and developing digital solutions. Then in years 7 to 8, students learn general purpose text-based programming such as Python, which we're going to look at today. Then in years 9 to 10, students can then build on what they've learned in earlier years and learn object-oriented programming. All right, so our 6 fundamentals of coding. We like to use the metaphor that coding is just like baking a cake. So to start off with, you have sequencing. So how, like when you're baking a cake, you have to follow a recipe, right? So you have a specific set of steps that you have to follow in a specific order to get to an outcome. And you can follow those steps. You could follow them in any order that you want. You could put them in any order that you wanted into your program. But ultimately, there's going to be one sequence of events which is going to be the most effective. So for example, like baking a cake, maybe you have to mix your dry ingredients together, then you add your wet ingredients, and then put it in the oven and cook it, right? Now, that's a great order of events right there. But if we did that in a different sequence, so if we had the dry ingredients and then we put it into the oven and then we added the wet ingredients after it came out of the oven, it'd be a mess, wouldn't it? So ultimately, while you might still get an outcome which could be similar-ish to what it is you're after, ultimately there is going to be always one ideal sequence of events, and that's what we want to try and find. Then we have branching, so that in programming we'd use terms like if-then, those sorts of things. Basically saying if a certain condition is true, then something happens, but if it isn't true, then something else happens, or if a different condition is true, then something else happens. So for example, when we have our cake in the oven, then it would be a matter of if cake is cooked, then take out of oven, else leave in oven, continue cooking, that sort of thing. So different directions of action that we can take in order to get to the end of our program in this case. We have iteration, so those are loops that can happen multiple times. So for example, if we were, again, baking a cake, we have eggs we got to put in, then maybe for every egg we have to crack it, we have to get it out of the shell, we have to beat it, and we have to add it into the rest of the ingredients. So those are 4 steps, 4 instructions. There might be 4 lines of code, and rather than having to put them in the recipe, for example, 5 times, you would just say for each egg do the following. So it makes looking at code a lot simpler, and it makes it can also get rid of a lot of potential for human error as well. and miscommunications, those sorts of things. Arithmetic, that's your basic stuff, add, subtraction. You know, I want 3 sticks of 200 grams of butter. That's a lot of butter, but oh well. Those sorts of things. So ultimately we know that that means the recipe needs 600 grams of butter, but maybe we only have access to 200 gram blocks. So being able to identify that 3 times 200 equals 600. Data storage. So that is, as term we'd use in programming would be variables. So storing data in a way that we can then access it later. So in this case, it might be the method, for example, so we can look at it and see instructions, or for example, in the baking a cake example, maybe our oven is a variable. So we have put our cake into the oven, and then after a while, I will get my data, or in this case, I'll get my cake out of the oven to move on to the next step. Data input, data output. In the recipe example, our data input, those are things like our ingredients, they're the equipment that we use, they're even ourselves, because we're the ones who are physically making the thing happen. So data inputs are the things that we need to put into a program to make it work. So all the information that we need to allow the program access to, and data outputs are then, in the cake example, the data output would be the cake. So it's what we get as the output of the program after we finished making it. Double check, no questions so far. Nope, great. As I was saying before, in case anyone's just joined while I've been nattering along, if at any point you have a question, feel free to just type it into the chat bar, and then I'll get a little notification, or I'll check for one every now and then, and I can have a look over at it as well. Okay, so our 5 principles of learning how to code. So these kind of do what they say on the tin, but we think they're really important to understand. The very first step of coding is to make a plan. It's best when you're making a program to not rush into things, just take a step back, decompose everything into smaller, simpler steps, so that if you have a problem, you can look at your plan and identify that, okay, I can see that that was where I went wrong. That's what I need to fix. Do one step at a time. So again, that kind of comes down to that problem decomposition. So rather than rushing through and doing everything at once and jumping all around the place, by taking things slowly and steadily and following that plan that we've just made, you're much less likely to encounter major problems further down the road. Have a go. So even if you have no idea if you've got it correct, just give it a go, run the program, run the code. See what happens. Worst thing that can happen is it doesn't work. Oh no, how horrible. We'll just try it again. So testing your code kind of does what it says in the tin. Obviously, you have to test and debug your code, but there's nothing wrong with that. There's nothing wrong with having to go through a few iterations of your code before you get to the final version that works, especially when you're following that plan step by step. And finally, resilience, don't give up. So obviously, even if you have tried 1,000 times and it's just not working, that doesn't mean that you aren't going to be able to figure it out in the end. Just got to power through. Okay, we're going to skip this one. Okay, this is more about Scratch. It's an example of a game that you'd be able to make, a quiz game that you could make if you were at years 3 to 4, but we aren't going to worry too much about it. That's visual-based programming, Scratch. So basically, as you can see, they're just blocks that have very little text on them. And so students can see the blocks, they can acknowledge that, all right, I know that that block does that specific thing, so I'm going to grab that block and put it in, and then I can go hunting for a different block that I also know does this other specific thing, and I'll pop that in, and building a program like that. So building it with blocks, kind of like building Lego is an example I like to use. But we're going to focus on text-based programming. So obviously, as you can see, text-based programming basically just means that it's very little is done for you. You have to actually type everything out yourself. You might be able to have access to pre-made libraries of code, but ultimately you have to be able to identify everything yourself and write it all out and test it and figure it out. Yep. So we're going to be using Python and idle. Let me just turn this over. Yep. There we go. So this is what Python looks like. You don't need to be scared. We're going to go through everything step by step. It's actually very close to plain English. I know a lot of people say that programming is kind of like learning a foreign language, and I guess in some ways it is. But the great thing about Python and programming is that, I mean, it's a foreign language, but it's a foreign language that is also somehow in English. So a bit of logic can help you really easily identify what happens in each step by step. All right, so on the left you can see the code, and on the right you can see the output from idle. You can see that it's a text adventure game, so that means it's a non-linear story, just like Choose Your Own Adventure books from the 90s, which is a bit beyond me, unfortunately. We also have Trinket over here as well. So those are two different tools that we're going to be able to use today. It's up to you which one you would prefer to use, depending on if you had a chance to download idle or not. But we're going to be building a quiz, kind of like the one that you can see here. In fact, actually, this is the one that we're making today. That's all right. These are some kinds of the projects that you can make with Python. There's a whole bunch of other options as well. These are just a few, but these are some great ones that students can really enjoy making as well and really get engaged with. All right, so microbits we're not going to focus on too much today. They're more for the next few PDs, but this is what a microbit is. It's a it's a microcontroller. Basically, it's a bit like a microcontroller. Some people like to say it's kind of like a mini computer that can only do like a half a dozen things or so, or a dozen things, but they're actually very, very powerful tools, especially for introductions to microcontrollers. So as you can see, they have a 5x5 LED grid. Those are basically just individual pixels that have been separated with some negative space in between them. They've got, so that sort of acts like a mini screen, basically. We have two buttons. We have A and B. We have an accelerometer built into it, and that's it can sense things like if it's being, if it's shaking or if it's tilting. And we also program microbits with Python, so they can help you build your own gadgets. You can display messages on the LED grid. You can program the buttons to change into emoticon faces. You can program the accelerometer to respond to different gestures, so it might become an earthquake detector, so it can be really easily integrated into subjects like earth sciences and those sorts of things. All right, so that's that out of the way. So before we get into it, questions to start off with before we start making the projects? Had a few people join. Excellent. Great. Okay, so for those of you who've joined midway, my name's Eloise. If you have any questions, just feel free to put them into the chat bar and I'll hopefully see them as I'm nattering along. Okay, so to start off with, so there's two different tools that we can use, as I was talking about before. I'll just close this PowerPoint now. We don't need it up anymore. Go away. There we go. Close, please. There we go. So we have two different tools that we can use. I'll just share my screen one more time. So we can either use idle, which is what we can see up on my screen right now. It's a program I think a few of you might have downloaded. If I can get my face out of the way, then excellent. There we go. It's a very basic way of using Python, but it's also a very powerful tool. So this is one option that you can use, but if you didn't get a chance to download Python, that's a-okay. There's also an online version called Trinket. You can find it just by Googling trinket.io. You do need an account for Trinket, but for the most part, you can just sign in. If you have a Gmail account, there are a few other things that you can use as well, but it's also a very easy version to use, and we'll try and run them sort of concurrently, but we'll see how that goes. And they work in pretty much the exact same way, so you haven't got to worry too much if you're using one over the other. I'm probably going to stick with idle today, though. All right, so to start off with, we are beginning with, if I can find the right page, here it is. Okay, so we're starting today off with a wonderful program called Geometry Turtle. So first of all, we'll just give you a basic introduction to idle and how Python in general works. So first of all, I've opened up idle and I can see these three little arrows pointing to the side. First of all, this main screen that we're looking at is called the shell. Basically, it's where we're going to see all the things that we're putting into our program. So everything that we're about to write, this is where we're going to see the output of it. So in the baking the cake example, this is the finished product just here. This is our cake. So these three little arrows pointing to the side, they tell me that the shell is ready to receive more commands, more instructions. So command basically being an instruction to the computer that I can tell it to do, or I can automate it. But it's telling me, okay, I'm ready to go, ready to receive information. So some really basic commands that we can use. One of the most common ones is one called print, just like that. You can see when I typed it, the text just went purple. It's a little bit hard to see, but it just went purple. That basically just says to me, all right, I know that that is a pre-made function in Python, in idle in particular. So when I type that and I give it a bit more information, it knows what to do with it, basically. So prints, and now I might just tell it to print hello world. Now, when I put those inverted commas in, it turned my text green. That tells me it's a string. So basically just, it's plain text. It's not going to try and do anything fancy with this. It's going to just, it's exactly what I've written. It's not going to have any functions associated with it. It's just text. So if I print hello world, and now if I hit my enter key, it's going to write for me, hello world. So it's just like printing to a piece of paper, only instead of paper, it's our screen, funnily enough. The same time, Python's also very useful. Maybe if I wrote just write print and then hello, it's going to go hello. That's not a thing that I can do. I can't do that. What do you mean print? So I just know then that I have missed something, which is very easy in Python to forget brackets or to forget apostrophes, because they're all very important things that help the computer understand what to actually do with the commands that we tell it. So if I even just miss a bracket at the end there and I do that, nothing's going to happen because it doesn't know that I've finished the function yet. At the same time, if I did that, again, though it has that end bracket there, so it thinks it's finished, it's also in plain text. So again, it has no idea when the string is actually supposed to end because I haven't put in the end quotation marks. All right, so to make a program in idle, I'm going to go up here and click on File, click on New File. If you're in Trinket, then you can come over to here where your name is and click on New Trinket, and you'll get this sort of screen here, which is just totally blank. And I encourage you to work along with me if you're interested, because it'll make life a lot easier. So we've just talked about strings. Yeah, oh, so the great thing about Python as well, actually, I'll just show this really quickly. I'll close up that program there, I'll get our shell back up. The great thing about Python is that it's very smart. It's a very smart program. So if I just told it, I can actually combine two strings using arithmetic. So if I said hello and then plus world, what I'm saying is, okay, I've got two strings inside this print. I need to print both of these two strings, and I just need you to smash them together. Just with that plus, I need you to put them both together and print out exactly what's inside these two brackets. If I hit enter now, it prints out hello world. Even though they aren't numbers, it'll just put them both together. Thing is though, because there isn't a space in there, I'm just gonna, sorry, I've got someone who's got a noise in the background, unfortunately. I just don't know who it is. Let's get it. There we go. Great. Sorry about that. Okay, so with these two strings though, what Python can't do is it can't look into them and say, all right, those are two words, so there needs to be a space in between them. It's going to print out whatever is in those two strings, because the strings could be symbols, they could be numbers, they could be anything. So if we want to have a space in between these two, I need to put the space in myself. So I need to say print hello space plus world, or I could put the space in the beginning of world if I wanted to. There we go. So then we got variables as well. Variables, we were talking before about how they're just storage places. So again, we've got, I could say I wanted a storage place called number1, and I want to tell number1, when I say number1, what I really mean is I mean the number 5. And yep, now idle knows that. Maybe I also have one called number2, and when I say number2, I really mean the number 3. So now I could say, print for me, number1 plus number2. And it's going to go back and it's going to read what's stored in each of those variables, and it'll add them together for me. And I've got 8 right there. Perfect. All right. So now we'll get started with that first project. So I'm going to make a new file in Python, in idle rather. So if I can get this out of the way for me, here we go. Right. So geometry turtle. Now, when we're making a project in idle, one of the, in any kind of programming form anywhere really, one of the most important things to remember to do is to put in comments. Because if we don't put in comments, then we might totally forget what it is that we're writing, especially if we're doing a longer project or a longer program, which we have to do over a few different sessions. So what a comment is if I put a hashtag in, like that, it's going to turn my text red. And now, no matter what I type in this, on this specific line in idle, whenever I run the program, idle is going to just ignore that line. It's going to just pretend it doesn't exist. So it makes it much easier when you have, when you need to put in those comments. So you want to make sure you remember what each thing is. So it can help you sort of do headings. It can help you write your plan, for example, if you're working with students and you want to make a plan step by step before you actually start programming. Is you could in comments write step 1, step 2, that sort of thing. And then you can go through and put lines in between here and sort of subdivide it in that way a little bit. Start off with geometry turtle. First thing we want to do is we want to tell it we want to use turtle code. Now, when I say turtle code, that's basically like a little, we call it a library in Python. And basically it means, what turtle is it's a way of incorporating images into text-based programming. So we could say we want to draw something, we want to have a graphic of some kind. To do that, we need to use turtle for Python. So to tell idle though that we want to use Python first, so that we want to use turtle, we need to actually directly say import turtle. And then you would do the exact same thing over in Trinket as well. So we're going to say import turtle. That says to at the very beginning, okay, you didn't know the functions from turtle before, you need to learn them for me very quickly because we're about to start using them. All right, so next thing we want to do is we want to create our turtle, which is going to be the thing that we use to draw with. Oh, I just realized I never actually showed you what we're actually making in the first place. We're making this game over here. My bad, sorry. So if I run this program over here in Trinket, as you can see, it's going to start drawing for us some shapes. We aren't going to go quite to that extent. We're going to just stick with the triangle and the square probably. But as you can see, it has created a little place for some pictures, and it starts drawing it for us bit by bit. And this arrowhead here, that is what we would consider, that's what we'd call our turtle. So first of all, we need to create our turtle. We need to create a little arrowhead. To do that, the easiest way is to actually assign it to a variable, so that when we're going through and talking about our turtle and say our turtle needs to move or turn or whatever, we can just refer to it by whatever name we've given to it. And in this way, some people can be really funny and give it a human name. I just like to call mine Bob. Bob equals turtle.turtle. Now, what these two things do here, what I'm basically saying is, first of all, I'm referencing turtle with a little t means I'm telling it, okay, you need to now be looking in the turtle library, because a library has a vast array of functions that it'll import for us. When we imported it up here, there's heaps of functions that have come with this. We're now saying, all right, we're looking at the big T turtle function of the turtle library. Now that's a bit hard to wrap your head around at first, but it'll make a bit more sense when we're looking at some different functions. But basically from the turtle repository of functions, we want the turtle function. So now I know that every time I reference Bob, I'm actually talking about my little arrowhead, my little turtle guy who's going to draw for me. So first of all, let's start off by drawing our triangle. Now, what I'm going to do first of all is we're going to use iteration, like we were talking about before with the cake. So we're going to say, here's some code, do this a few times because it makes it much easier than writing it out step by step. I could say for each single one, move 100 steps, turn, move 100 steps, turn, move 100 steps, turn. But if we were looking at a shape that had 20 sides and we still wanted to draw it automatically, that's a lot of code to write out to get one shape. So even though a triangle is pretty simple, we're still going to do it this way to learn the concepts. So I'm going to say for I in range 3. Now, what this does is I'm basically saying, so I is like a tiny mini variable, which is only relevant in this particular, in the following loop, basically. Because now if I go down, I'm going to write inside the loop down here. So I'm saying for every item in range 3. So basically it's created like a little mini list for me of 3 items. They're just empty items. But for every item in 3 times, basically, we need to do the following text. I hope this is making sense so far. I'm not getting any chat messages, so I'm hoping that means everything is all good. Great. Okay. So for every item in range 3, so basically 3 times, we need the following code to happen. And by putting this semicolon, colon, whichever one it is, putting the semicolon here, and I hit enter, it's automatically indented for me. So that means I know that whatever I write now is only going to happen inside this loop. It'll be read as many times as it needs to for the loop, but nothing else will be able to access it. So for I in range 3, what we're going to do is we're going to tell Bob to move forward a little bit. So we're just going to write bob.forward. Oopsie daisy, 100, like that. Now again, what that does is I'm saying Bob, so that's basically like saying turtle, so accessing the turtle repository of functions, the turtle library, we need to move forward by 100 pixels or 100 steps. So, because forward is again a function that you can access from turtle. So in the same way, if I hadn't given my turtle a name, I could just call this turtle.forward 100. And it would function in the exact same way as this in terms of accessing a particular function from the turtle library and performing it. However, because we've already given our guy a name, I'm going to call him Bob still. Bob.forward 100, and then I'm going to tell Bob, okay, Bob, now you need to turn left by 120. So once again, we're accessing a function from the turtle library of functions. And what we're doing is we're saying, now you need to turn left by 120 degrees. The way we calculate that is, so basically we want a closed-in shape, right? We want a shape that actually is a complete shape. It isn't just a line that sort of goes nowhere. So in that case, that means we need to start and finish in roughly sort of the same-ish place, or the same, facing the same way, basically. So that means it needs to go the full 360 degrees around. Now, I know that there are 3 sides in a triangle, and we're just making a triangle at the moment. Because there are 3 sides in a triangle, all I have to do is divide 360 by 3, or in this case, 120. So I'm basically saying, Bob, every time you come to this loop, you need to turn left by 120 degrees. So now if I run this, and to run a program like this in idle, what we can do is up here in run, you can run the module and it'll ask you to save. That's okay. We'll save it. My computer's going to be quite slow, but that's okay. I'll save it to my desktop and I'll just call it PD turtle. Okay, and now it'll automatically come here. A little screen will pop up for us. That's our turtle shell, our turtle graphics screen, and it's drawn us a triangle just like that. Now the same sort of logic applies for a square. I won't go through the square right now, but what I will do is I'll teach you the slightly more complicated way. So that's all well and good. We have a triangle working now. Excellent. I'm now going to comment this out. We're going to try and do it a similar way, but a way that's going to be a little bit easier to adapt for a game, so to speak. So first of all, we're going to try and do it so that you can pretty much make any shape that you want to. So first of all, we need to ask for we're going to try and ask for how many sides that the particular shape should have. So we're going to ask for number of sides. And what we're also going to do is we're also going to convert whatever answer we get given into a number. Now, we haven't gone through a few of these features just yet, so we'll go through these now. First of all, there's a feature in Python called input, which basically a little thing will pop up, a little string will pop up, and it'll ask you to type something in and provide input. So if I show you this game over here, which is the next one we're going to do, if I run this, the first thing that pops up is, what is your name? My name is Eloise. And so I'd give an input there, and it's automatically put it out into a string for us next as well. So if I go back into over here, the way we do that is to start off with, we're going to put it straight into a variable. We aren't going to just ask it. We're going to put it straight into a variable. I'm going to call my variable sides. And so it's going to be input. How many sides will the shape have? Now, what that does, first of all, is as soon as the game starts now, this question just here that I've just typed is going to pop up for us. And it's going to have a little space for us to type. That's what the /n does. That basically just means new line. So it'll move the cursor onto a new line for you, which makes it much easier if you have a game which has lots of different questions and needs lots of different input. So it'll ask for an input of how many sides will the shape have. So we'll run this. I'll show you what I mean. So straight away, whoopsie daisy, we don't need turtle anymore. Not just yet. Go away. Here we go. How many sides will the shape have? Straight away, oh, well, the new line thing works in Trinket, but obviously I've not quite done it correctly for Python. That's okay. How many sides will the shape have over the shell? Here it is. Okay, now if I type something in right now, nothing's going to happen because I haven't told it what to do with whatever input I get. So we'll go back over into, oh dear, come on. Oh goodness, I think it's crashed on me. That's all right. We're going to just over here. There we go. And we're back. All right. What we need to do though is just in case we get someone who's really funny and decides to put an absolute gobbledygook, we're going to also need to convert this into an integer. An integer is basically just a fancy word for a number, basically, a whole number. So we're saying, because also means, because the input that we give will automatically be a string. So even if it is just a number, we still want to actually put it into a form that Python can read. So we're going to say, all right, whatever it is I put in, turn it into a number so that I can actually read it. Okay, so that's that one done. So now we need to do some fancy shape math, which is basically just a fancy way of saying calculating what angle it is that we need this thing to turn at every time that it goes onto a new side of the shape. So again, we're going to put it into a variable. We're going to call it angle. Angle, and again, as we talked before, it's 360 degrees. So 360 divided by sides. And then finally, we're going to actually draw the shape. So we're going to draw the shape. To do this, we're going to use one of those loops again. But this time, we want to make sure we do it in a way that it can dynamically adapt to however many sides the user has told it to have. So for however many items are in the range sides, so in other words, however many sides I have told Python I want to have in this shape, you need to do the following. Again, we want to tell Bob to go forward by 100 pixels. And then we also want Bob to turn left by whatever angle it needs to go at, which conveniently we've already calculated. So we can use angle there. So in this way, we can insert, again, the variables into the places of the whole numbers that we've given it before so that it can adapt to the changing inputs that a user can give. So now we'll save that and I'll run that again. How many sides will the shape have? I want it to have 4 sides. It still does not want to let me type. That's all right. What I might do is I'm going to grab this text and I'm going to put it into Trinket instead because Trinket will work for me. All right. And now if I hit run, and over here, how many sides will the shape have? The shape needs to have 4 sides. And there's our square for us. And if I ran it again, I could say I want it to have 5 sides. And then it'll draw a pentagon for us, just like that. So no matter how many times I run it, I could try and trip it up, but it is always going to form a whole circle for us, just like that. Okay, and that is the first project done. I don't know what's going on with Turtle over here. It's really not wanting to work for me. That's all right. Okay, so before I move on to the next one, which is the space quiz, did we have any questions at all? All going good? Yes? Awesome. Okay, I'll just try and get rid of this guy over here. I might try restarting the shell just to make sure nothing weird's going on. All right, so we can close this one now. There we go. All right, so what we're going to do next is a space quiz, which is this one just here that I was showing before. Oh, I'm not sharing my screen. Try that again. Over here. Okay, this one that we were looking at before. So again, I'll run it. What's my name? My name's Eloise. Hello, Eloise. Welcome to the space quiz. What's the name of something orbiting a planet? That's a moon. Which planet has rings? That's Saturn. Correct. What is the third planet from the sun? Oh no. Pluto. I don't know. I wasn't very good at science. Pluto. The answer was Earth. Oh dear. Oh well. I got 2 questions right. Thanks for playing. So just some little things here and there that sort of turn it into more of a game as opposed to just a straight program that you make, which is what, again, one of the things that keeps students really engaged with it. So again, I know it looks a little bit intimidating, the amount of code that's over here, but we're going to break it down. A lot of it is stuff which we just did before. And okay, we'll try making a new file again. All right, so first of all, what we want to do is we need to import a library called random. So we're going to just set up the game first of all. We're going to import a library called random, which, as you might be able to guess, basically just gives us the ability to randomly select something from a given range, basically. Makes things much, much easier because it means that we haven't got to try and figure out a way to do it ourselves. So what we're going to use now is something called a dictionary. So what a dictionary is, it's kind of another form of a variable in that it's a way of storing values. So we store values in the form of key to value, just like that. Now, in this way, in this game, we can think of it as question and answer. So the way that we're going to actually implement this is by, first of all, because it's a type of variable, we're going to give it a name, questions. Questions equals is assigned, is it probably a better way of saying it. I'm going to open some curly brackets just here, which tells idle that, okay, what is inside of here is what needs to be considered as part of the questions dictionary. So now I'm going to type in my questions. So what is the third planet from the sun? All right, and then again, we had that form before of key to value. So just like that, I've got my key there. Now I need to give the key a value. The value is going to be the third part of the sun, as I got wrong before, it was Earth. All right, so now I need to give it the next key and value in the variable, which we're going to indicate by putting a comma in and hitting enter. So again, then what is the name, see Daisy, the name of something orbiting a planet? And the value for this one is going to be the moon, is going to be a moon. And then our final key and value, which planet has rings? Our value for this one is going to be Saturn. Again, they're all strings, hence why they're in there. Because that was our last key and value, I haven't got to put a comma in at the end back there. All right. So the last thing we need to do in setting this up is, remember I had a score. I got 2 out of 3 correct. To figure that out, I need to put in a variable, which is very simply going to be score. At the very beginning, because we're setting up the game, I need to assign it to 0. If I don't do that, then every time that I run the game, score might get higher and higher and higher, and it might lose track of what my score actually is. All right, that's the setup done. Next, we need to actually introduce everyone. So that was when it asked me for my name. So again, we need to ask for an input, and we're going to assign it to name, because if I don't assign it straight to a variable, then even once they put the input in, I'm never going to be able to access that information again because it isn't stored anywhere. So by putting it into a variable, and that means that I can actually call on it later. What is your name? And well, then we want to print out a combination of a few things. We're going to print out hello, and we're going to add in a variable so that no matter what it is I put in as my input for my name, it'll always appear in there. I could put an absolute gobbledygook if I wanted to, and it would still come up. Welcome to the space quiz. And there we go. Right, so we've been introduced. So now we need to start actually asking the questions. So to do this, we're going to use, we're going to call it a game loop. To do this, we're going to use something called a while loop. So I'm going to say while len questions is greater than 0. So what I'm saying here, what a while loop is, so when I say while, what I mean is the loop needs to continue executing over and over until whatever condition I put next to it becomes false. So in the cake example, for example, I would say while cake is uncooked, continue baking. So it'll continue cooking the cake in the oven over and over and over again until the cake has finished baking, until it is no longer uncooked, and then the loop will stop. And the program will keep going. In this case, it would be I would come over and take it out of the oven, that sort of thing. So while the length of questions is greater than 0, so what we're going to do later on is when we start going through it, we're going to actually be deleting the questions one by one as we go through. So basically, while there is still an item in questions, while there's still a question to go, we are going to, first of all, what we need to do is we need to convert the dictionary keys to a list and pick a random question. Now, that's a bit of jargon just there, but what it basically just means is all the keys, so again, all the questions that we had in our questions up here, we need to convert those into an actual list, because right now we might think of it as a list, but Python doesn't know that it is one yet. So what we're going to do is we're going to, in a new variable, which is going to be called question, even though it's very similar to questions, because it has that one letter difference, because this one has an S and this one doesn't, they are still considered a different variable from each other. And Python can still differentiate between them. So question, we're going to random.choice. So again, we're referring to the random library, just like with Turtle before, we're referring to the random library of functions, and we're specifically using the choice function. And what we're doing is we're choosing from the list of questions dot keys, there we go, and I'll go through that now as to what that's, because again, that's a lot of bits and pieces to put together. So I'm basically saying, from the random library, we need to randomly choose from our list of, so this is going to generate a list of the keys from our questions up here. So it'll create a little sub list of just our questions here, just these ones. It'll, from this list that has just been generated, it's going to randomly choose one of the questions. So no matter how many times I run the game, it's almost always going to be in a different order from each other, basically. And that's more relevant when you have a list of like 20 questions or so. So after that, once we've got the question to say, first of all, we need to actually figure out what the answer to that question is. So we've got the key, now we need to get the value for that one. So answer, sorry, whoopsie daisy, get the answer to the question. And we're going to make a variable called answer. Answer needs to get the questions question. So, so that's a bit odd to think about, but basically, each of the things from the question list, it's going to find the answer to it from the questions dictionary that we had at the very top, basically. So we're going to now say, now the player needs to actually take a guess. I think I've missed something here. Where is it? I'm not sure if this actually has a print anywhere. That's all right. We'll figure it out. Player takes a guess, whoopsie daisy. So guess, again, put it in a variable because it needs to be information that we need to be able to access later on. Guess needs to be input, question, oh, here we go, plus new line. So as you will hopefully be able to interpret by now, I'm going to just put some new lines in here so we can actually see what's going on. Here we go. As you'll hopefully be able to interpret by now, we're going to ask a question. So it's going to have that little input bar pop up for us with one of the questions from up here, one of the questions from our list, and I'll put it onto a new line, at least it will in Trinket. And then whatever it is that the user then types in, hits enter, that will be stored as their guess. So we now need to check for, whoopsie daisy, we now need to check for if the guess was right. So we're going to do this thing called if guess dot lower. Is answer dot lower. There we go. So what this is I'm basically accessing the lower function of a variable, which it basically just means that no matter what information was stored in those variables, as long as it was a string, it's going to convert everything that's stored in those variables to all lowercase. So that means basically in my game up here, if I play through it again, as always, third planet from the sun, I know it's Earth now, but even though I know the answer has a capital E in it, which I can see over here, just there, even if I write that in lowercase, it's still going to consider it as correct because everything has been automatically converted to lowercase in the one time. So, and what the double equals sign here means, that means is exactly the same as. So, if whatever was in guess is exactly the same as whatever is an answer, assuming that they're both in lowercase, then something needs to happen. So what needs to happen? We need to, first of all, we need to print correct, and then we need to actually add 1 to our score. So to do that, we're going to do score plus equals 1. That's just a programming way of saying add 1 to 1. If I had a minus equals 1, that would mean no matter what score is, take whatever score is and take 1 away from it. And so again, yeah, plus equals means whatever score is, take that number, add 1 to it, and that needs to become the new value for score. So if that happens, that needs to happen. Else, so basically, oopsie daisy, that was a bit, that's funny, typed my name by accident. So basically in any other situation, if there's anything different at all about guess and answer, then instead we need to print the answer was plus what the answer actually was plus full stop, and then close our brackets like that. So now, if you remember, this whole thing relies on a while loop. So it only asks each question once and then it deletes it from the list of questions. So the next thing we need to do is we need to delete the asked question. So we're going to use a function. We're going to just back out because I was still in the else loop just then. We're going to say del, which basically just means delete questions, question. So I'm saying whatever question it was that we are currently looking at, that we just asked, we need to delete it from the question, that should be questions. We need to delete it from the questions variable up here. So whatever position we were in, whatever question we were asking, we need to delete it from that list. And then that's how we're going to then reach the 0. So because of course, once they've all been asked, and they've all been deleted, then we're going to eventually get to the point where questions has nothing left in it. So questions, the length of questions is eventually going to hit 0, and then the while loop will finish executing. So finally, we just have to finish the game off. We have the game end section. So that'll just be a matter of saying, when the game is ended, we need to print, you got, and remember we had that score value variable that we've been working on, oopsie daisy. It should actually be string score. So just like the int that we had before, where was it? It's gone away somewhere. With the int before, it'll convert whatever was in score to a string. So that doesn't mean it's going to change for into FOUR, but it'll just turn it into a plain text string that can be displayed very, very easily. Score plus questions, oopsie daisy, questions, right. Go. And then finally, we're then going to print at the very end of the game, thanks for playing. Oopsie daisy. There we go. It's one of the most frustrating things about typing with Python is just remembering where you have to have spaces and commas and things if you want to make your sentences grammatically correct. But I'm pedantic, unfortunately. All right, let's have a little look and see what happens with our game now. And it wants me to save it again. That's all right. PD quiz. And then we're going to run it. Down here, what is my name? My name is Eloise. What's the third planet from the sun? It's Pluto. I know for sure. Oh, I was wrong. Which planet has rings? That would be Saturn. What is the name of something orbiting a planet? I'm now going to say moon in all capital letters. Sorry about that. In all capital letters. Now, even though I've written it all capital letters, thanks for playing. I got 2 questions right, and I obviously forgot a space somewhere. That's all right. Thanks for playing, Eloise. And the game is done. So, a very, very simple game, which as you can see, at first glance, it might look a bit complicated, but in reality, it's actually very simple when you look at it and try and break it down into what each specific line does. So I'll stop sharing that one now. All right, so we're almost finished. Did we have any questions at all about how that all works or what different features and things do? Everyone's been very quiet, so I'm very worried that I haven't explained anything. I haven't explained something.
Look, I'm really part of things, so everything's new to me, so I'm just going to have to sit down with it and have a look at it, really.
Great. Awesome.
Yeah.
Okay.
I've been playing around with Arduino a bit, so I know that side of things a little bit better than this, so I'm just going to get my head around it. So.
Sure.
Yeah.
Whoopsie daisy.
It's going to be a long learning curve.
Yeah. So we do have a few resources available for understanding Python a bit more. I'll send them through to our group chat. First of all, we have this one, which is our Python cheat sheet. So basically, it's what I've got here in front of me, only in pretty colors instead. These are a lot of the basic functions and such that you can use in Python, with a really handy explanation off to the side about how you use them and what they all mean, basically. So it's very handy. It's also a very useful resource to print off and give to students as well, because obviously sometimes when you Google these things, because Python is such a popular language, especially for students, sometimes if you Google it, you'll just be sort of smacked with a whole lot of information with far more complicated examples than you actually want. So that's a great resource just there. We also have, if I can find it, thought I'd saved it here. I guess I hadn't. That's all right. So if there was anything that you think you might have missed at all during all that, because I know we had to go through it all very fast because we had a lot to get through, then our YouTube page and also our Facebook pages, we have a huge variety of online tutorials that are run sort of in a similar way to this. Sometimes it might be a little bit more casual or a little bit more formal, but they're all recordings that our tutors have done and made, which go through very similar content in a very similar way, using very similar terms and metaphors and those sorts of things. So especially if you're sort of thinking, oh my goodness, what I've got myself into right now, then you can very easily access those. I'll just try and find the link to our YouTube page, but I'm not sure where I've saved it. Otherwise, before I finish up, so the next few sessions, if you're here with us for the next few ones as well, we're going to be using microbits. I was talking before about how they're these little microcontrollers that have little screens that you can do things with. Now, if you can get access to one of those, we think it would be really useful if you could get one for the next session, because they're very not much easier to understand when you actually have one that you can fiddle around and play around with. But at the same time, if you can't get access to one, then I have been able to find an emulator for one. Again, if I can find the link to it, here it is. I'll pop this one into our chat as well, just here. You can access that one just there. So it'll work just like a microbit does. You have to sort of, when you're writing instructions and things for it, write microbit dot insert instruction here for those of you who might have used them before, but we'll go through all that again when we're actually using them if you're here for that one as well. But yeah, so feel free to have a bit of a play around with that, see what you can do while we're there. Here we go. Can I find the YouTube link here? Here it is. I'll just send through. I'll send through all of this. So these are just all links to our various social medias and platforms and such. So if you ever wanted to get in contact with us, then these are the ways to go about it. That's pretty much it from me. Did we have any final comments or anything from those of you who are still here? Because we're still getting used to running Python workshops with and content as well. So if you had any comments at all for how we ran it, then we'd love to hear them. Not sure who's still here.
Eloise, have you got copies of the script, like the 2 little activities you did then? Have you got them that we?
So I can.
I was trying to copy as we went along, but.
Yeah, I understand. I was probably going a little bit quickly. So I'll send through this link just here, which is the space quiz we did at the end there. That's that one just there. That's the Trinket IO version. And then this is the, this uses for loops for the geometric shapes. It's a little bit different to the version that we finished up with where you had to ask for input and stuff, but it's definitely a great place. It still covers the same basic concepts. I'm not sure if I have one with the fancy for loop. Or what I can do is actually, if you're willing to just stick around for a moment, what I can do is, otherwise feel free to pop off now. I realize that the session is finished. So thank you for those of you who have joined us today. Again, if you have any comments or questions at all, just feel free to send them through. But I can do this and I can just save this myself. All right, this is going to be called Untitled or something or other, but here we go. I've just quickly put this one together in a new Trinket on the website, but there's that one as well. So that should be the version that I finished up with, where it has the one where you can put in your own number of sides and such, but let me know if it doesn't work, but that should be correct.
Yep. Cool. Thank you.
All right. So yes, thank you for joining me today.
Excellent.
And hopefully I will see you in the next one.
No worries. Thanks, Eloise.
Thank you very much. Bye.
Yeah.
Bye.